Next speaker will be Marco Bersani, which is the president of Circular Materials. It will be online, right? Hopefully it will work.
Yes. Can you hear me okay?
Yes.
Okay, very nice. If you're ready, I'm ready.
You can go.
Okay. Good morning, everybody. My name is, as introduced by who was speaking before me, Marco Bersani. I'm the president of Circular Materials, and our company. I'm very happy to have the chance of speaking after everybody who's speak before me, because they already introduced and laid the basis for what we intend when we speak about circular economy focused on materials. So let me introduce you a very ubiquitous industry we might not always be aware of, which is the surface treatment industry, and especially the metal plating industry. At every second, every item in our lives, jewels, watches, electronics, buttons in our shirts and jackets, pretty much everything during its lifetime, every item has undergone some type of surface treatment. Usually you take something which is not very noble, some iron or some inexpensive substrate, and you coat it with something that imparts to the component some fancy properties, some nice looks, gold plating, silver plating, but also some functional properties, like, for instance, anti-corrosion properties. And so surface plating is a very big industry. Just in Italy is more than, it's 5,000 to 10,000 companies just working surface treating items. The problem with this industry is that if we take a step back and look at the journey, the metal that is put on top of a component has undergone before coming to its functional application, it starts in some typical faraway country where there's a mine. This is a nice copper open mine. It's very big, extremely impactful on the environment, because essentially you have to dig a huge hole in the ground to extract a tiny amount of metal which is embedded in rocks and minerals. So you dig the hole, take out the mineral, process it in the very large establishments, which, as you can guess by the copperish color of the soil around the industry in this picture, is not so clean already. And from all these operations, which are extremely soil and energy intensive and water intensive, you get some nice copper pure metal. So these are 10 nice copper ingots that will be shipped somewhere else in the world, further processed to get some copper intermediate that will eventually, in our case for the surface metal treatment industry, end up in a complex chemical bath where you essentially dip the uncoated component and you take out the coated component. So you remember, we had 10 copper ingots to start with, and let's say out of these 10 copper ingots, 8 of them end up on a functional bit. So where the other 2 copper ingots, the other 20% go? Well, it goes essentially inside in a waste treatment center, okay? Goes inside a much larger by volume sludge, and the sludge goes in a landfill, okay? So essentially, if we look back at what every single atom in that copper ingot has traveled through, it went from a mine to another type of hole in the ground, which is a landfill. And this massive inefficiency for a lot of extremely valuable metal, copper, nickel, zinc, tin, chromium, of course, and also for a lot of precious metals as well. Silver, ruthenium are extremely valuable metals that still end up in landfills because of intrinsic inefficiency in the industry, because recovering them is complicated, and it's mind-boggling that such value is lost and goes from the ground to the ground without ever seeing any functional application. Another secondary issue is you see this landfill, there's a lot of trees around, there's a lot of water in the ground. And the risk of this metal from being released from the landfill to
I guess, Marco, you cannot hear us, right? Let's try to connect again. Exactly. I was thinking the same.
Right, and so we can anticipate it. Well, let's wait another minute. Sorry for the problem. Always happen. Today is happening a little bit too much, but no. I would say sorry for Marco. They're calling us.
Voglio vedere se fa connessione al telefono.
Al telefono? Okay, seems to be connected again.
hi everybody again.
Yes, we are. Can you hear us?
Yes, I hear you perfectly. My apologies for losing the connection, but doesn't depend on me. Sorry, did you make it to the water body contamination by metals? I think this is where the connection dropped.
Previous slide.
Yes, the previous one.
Okay.
Yes, we were here.
Okay, so yeah, sorry. So essentially what happens is once the metal is in the landfill, there's an intrinsic risk of release of metal to the environment and to water bodies because of leaching, because of mishandling. So once the metal is in the ground, not only it's a massive loss of value, it's also an environmental risk. And it's not a theoretical risk, because if we look at the health of water bodies in Europe, the massive percentage of the water bodies are metal contaminated, and this comes mostly from industrial sources. Okay, and we're talking about heavy metals with high levels, high degrees of toxicity, and it's not anything that will go away over time. A heavy metal is there to stay until it's taken care of. So by witnessing this massive loss of value, this massive environmental risk, and the fact that we're dealing with extremely valuable metals, okay, both critical, technological metals, precious metals, we started thinking of applying our technology to the recovery of these heavy metals. These metals are now not recovered today because it's difficult, it's hard, it takes expertise, it takes competent people on board in the company when dealing with these industrial metal containing waters. So we used a process we developed over the last few years. And the beauty of our process is that while usually to take down metals, you need to add some sludge generating additives, some sludge generating chemical, you try the idea, the consolidated idea, the standard idea is to trap metals in some matrix so that they're essentially diluted in this sludge and something you can process, handle, and put in the landfill. We have a different idea, and we use one very nice and sustainable reagent, which is water. It's just we don't use water because adding water to water wouldn't work too nicely. We use water in a very peculiar state, which is so-called supercritical state. And essentially it's very hot and pressurized water. When you mix the metal containing wastewater with this hot and pressurized water, the magic in the thermal properties of water force the quantitative precipitation of the dissolved metal out of the water so that you can precipitate the metal and recover it as a pure metal powder, which you can easily reintroduce circularly in the production cycle as a secondary raw material, as any synthetic metal powder. So this is a very, how can I say, very naive depiction of our process, where essentially we mix in a turbulent fashion the two flows, one containing metal and one of very hot and pressurized water, to achieve something that looks like this. So typically metals in powder form are black, so not too much as fancy colors, but we recover a metal as a metal or metal oxide powder, which can be immediately be reintroduced in the value chain of metals. This is industrial. So we built these plants, we build plants. Now these are old pictures of our plants, but our goal is to put our modules right when in the location on site where the waste is generated. So reduce having hazardous waste travel too much, okay? And enabling whoever is generating the waste to immediately take control of the value of the metal they originally purchased and they were about to get rid of, about to dispose of. So recovering value directly for whoever is generating the waste and declassifying the degree of risk of the generated waste. We recover 99.9% of the metals that were contained in the treated water, okay? And we require no reagents, we don't generate any sludge. We just use very hot and pressurized water. Of course, we take energy, but the only form of energy we take is electricity. And we can recover most of the energy we borrow from the plant, from the system, reuse it within our own plant. Plus, water as our reagent is water, it can indifferently treat any type of waste. So we've treated pretty much every plating bath solution out on the market: nickel, chromium, zinc, palladium, gold, ruthenium, silver, and the process itself is not sensitive to the specific chemistry we're dealing with. So we think we're developing a platform that in our long-term goal will prevent any metal from undergoing the conventional treatment and disposal cycle, okay? We want to fully recover all the metals and preventing them from being released in the environment and keeping them in the production loop, in the production circle, the supply chain value of the metal, which is our take on heavy metal circularity from industry. We had an outstanding feedback from the companies we've contacted in the FOOC, also because, and this is a good news for whoever is attending this forum, is they're becoming increasingly appreciative of the improvement in their LCA and sustainability cycle. So this has become unexpectedly a major value proposition in our product. We're selling the product, and we're really eager to see where this technology will eventually manage to reach. This is pretty much all. You can find my contact here in case you need any follow-up or any more technical details, because this presentation was very high level, and I'm open to question if there's any question. Thank you.
So thank you very much, Mr. Bersani. It was a great speech and a great activity that you're working on. So
I simply want to say again, thanks. And also we invited them because we also have a partnership with the ADWA, and ADWA had invested in circular materials. So it's part of the CVC. So thanks again. We take